Morning, everybody. Today we're going to deal with the sign test again, which is Chapter 11, Section 1. And we're going to deal with it when your n is larger than 25. The test statistic that you use when your n is larger than 25 is a z-score, which is equal to the x that you get. Now remember that the x that you get is the smaller of the number of pluses or the number of minuses, whichever one is lower. You add a 0.5 to that value, and that's really actually a correction for the continuity, because this is a modified version of the normal approximation z-score formula. And then minus 0.5 times n, where n is your number of positives and negatives added together. And then the denominator is the square root of your sample size. Be careful with that. The square root of your n. Remember that that's actually the number of positives and negatives. It's not actually your sample size. I misspoke a moment ago out of old habit. So it's your number of your pluses, number of your minuses. Take the square root of that and then divide that by 2. That also means that we get to look at it as if it's a normal curve. And so to be able to find the critical values, we get to use INV norm alpha if it's a left-tailed test. If it's a two-tail, INV norm alpha divided by 2, and we take that value because it'll be negative and we push it over to the right-hand side as well so that it'll give us the positive. The normal curve is symmetric. And then you can do, if it's a right-tailed test, INV norm 1 minus the alpha. Now let me just throw this out at you. You don't actually have to do that. You can just take the 1 minus, or the INV norm alpha, and just make it positive. So it'll give you the same value either way. Alright. So we're going to do Try It Yourself number 2, page 587. It's chapter 11, section 1 out of the e-text. When you read through the problem, you're going to get that the null, over here, has the median being equal to 46. That's the claim. The alternative is that the median does not equal 46. Now, the alpha is 0.10, and because it's a not equals, in the alternative, we are dealing with a two-tailed test. So what I did was I used the INV norm alpha over 2, and so I took my alpha, which is 0.10, and split it in half. I did INV norm 0.05, and I got my negative 1.645. Now, if you look right here, you get your negative 1.645. And then, due to symmetry, I can just flip it over and make it the positive 1.645. When you read through the problem, you find out that the number of positives and the number of negatives are 57 and 34. So you add those two together to get your n, which is 91. Now they did say that there were 4 of them that were equal to 46. All of the ones that are equal you discard, you ignore them. Your x is 34. It's the smaller of the two numbers. And then you go to your z-score formula. I did 34 plus 0.5 minus 0.5 times 91. I did put the numerator in its own set of parentheses. And then the denominator is the square root of 91 over 2, again in its own set of parentheses. And you'll notice it's the square root of 91, and the 2 is separate. It's outside the square root. You should end up with negative 2.306. Well, that puts me in the rejection region here on the left tail. So what I'm going to do is I'm going to reject the null. My alpha is 0.10. Now, when I reject the null, I think about it as I'm actually putting a line through the null. And so my purple line goes through the null, and I look at the word claim. The claim has been crossed out, so there is insufficient evidence to support the claim. In other words, the claim's bad. And that's how we operate, using that sign test.